See, I could never. What is the criteria for a zero force member? Like, I just don't get it.
Like if there's two members that are like this, and there's like a connection point, anything in between, if there's only one, it has to be zero because there's nothing to like balance it out.
Okay. If there's just one like this or like this or like that, if there's just one, unless there is an external force there, there can be no force because that has a vertical component. There's nothing to, this does not do vertical components.
Okay.
Anything like this would be zero. So then, once you block that out, then it means that other things have to be zero also.
Okay.
Static.
Oh,
Background noise.
I love trusses.
So,
More of a frame gap.
you know, like this one.
Ours?
Yeah, you can't. That's okay.
No. It's the lowest 3D.
So, like this one. This one has to be a zero force because there's nothing here to
Okay.
kind of balance it.
I got
Same
you.
with EC.
And over here, this one.
Okay, not
This one has to be a zero. Right?
Wrong problem.
That's all right.
That's
Keep
37.
it going.
It's
37.
37.
That's what we were talking about.
Wait, so we're just going over trust right now.
Keep going.
Okay, I'm with you there. I found those two.
Okay, so if this one's
I know, me
zero,
too.
that one has to be zero
Gotta be.
because
Gotta be.
it's the same idea.
Oh.
Right? So then that one has to be zero.
Oh, because only one
Well,
force
if this one
applied.
is zero and this one's zero, then this one has to be
Yeah.
zero. Right?
It's all gone.
So you have
And
four.
so you really just have this taking all the.
So you have one big whooping triangle.
That's right.
One big
That's
bull
right.
Okay. But you really.
This zero force idea is very prevalent in these tests every year. Because they want to see if you get it. Because if you get it, it's easy. Oh, well, sure, that's it. Take it.
But why wouldn't you just not put those in there?
Because they want to know you get it.
No, like.
Wait a minute, you've got that on tape.
But.
Come to ONU where you can be amused by the
No, he's leaving.
Okay. I'll just shut up.
Anyway, you need to know this.
Okay.
So back to your other one.
Yeah, 33.
So
I even drew a free body diagram.
I would say free body diagrams the
Oh,
first
wow.
place to start.
I did that just for that.
I got it wrong. I didn't do that today.
You know, I saw Eric.
Oh, really? Look at that.
markers out here.
He brought his own.
Yeah, he brought him in too, but.
He brought them in,
Really?
he threw away all
That's
of
it.
them. He lets them dry out in the air and then they don't work, and he thinks they don't work.
You're supposed to store them with the cap down too, so the paint like goes.
You can also kind of suck on them. Okay, so this.
Oh, that makes sense. How did I not do that?
This one.
Only vertical force.
This one.
No.
So this is.
They did do
uh,
something.
I know that.
You did do something.
This is a 4-3. So you can. One thing you could do is just create this force triangle. You know, you've got these two. This one. So if this was weight, and this is B, and this is A. This was A, E. And you know this angle. Then you could find it that way. If you want to take a long time, you could like sum moments about A.
Yeah, I know.
But you don't want to do that.
You can just do this by summing forces.
How are the rules right here?
Yeah.
Right?
Huh?
You can just do it by summing forces in the y direction, can't you?
Yeah.
Point. You could do it if you recognize the direction of this.
Right. I think that's not.
That's probably the, well, that's how they did it here, so.
Oh, it is.
Yeah, because all they have is one equation in that case. I think I
Well,
used the wrong.
you know, I would not expect you to cut to the chase and do the most efficient solution, but
morning?
So like.
Yes.
4/5 times the normal force equals the weight.
Yeah.
Just solve it.
What's 120 divided by
Right, so they did the same thing, did a free body diagram, but instead of making it into a triangle, they just made it like this. They sum forces.
That's, okay, that's what I did.
You might want to confuse you. Which one?
I thought I missed one of the slides, right?
Can you do the 32 if we're done with that one?
Is this morning?
That was
32.
lucky,
I've already bought it.
Wow.
He's not feeling that rough.
Here's all the work I did.
You're right.
I was thinking about it. I was
Okay,
like, I mean, this.
so
This
you want,
tangent. Oh, D.
this is, this feet. So it's really just a free body diagram. Outside the normal force there. And the friction force will decrease the higher the angle, right?
Yeah.
So if we were to look at, this is our XY, then if you sum forces of the X, then we've got friction force minus W sine P. And so you need, in order for this to move, this has to be, you know, at 0 is right at the tipping point.
Oh.
So if we set this equal to 0, solve for p. You getting my best side? I don't know if this gives us anything. Friction, yeah, we need this for the friction force. So we've got N minus W cosine. This does equal 0. So we can get N, put that in as mu N, and solve for phi. That's what I would do. I don't know if that's the way they do it. So F is mu N, which is mu W cosine phi. And for F, that has to equal, so you notice what this does for us. It says mu W cosine phi has to equal W sine phi. So W goes away, and this is tangent phi, so you can actually, just from mu, get what the phi has to be. So D is the right answer, right?
Yep.
So that's another one. If you just remember this, that for an incline, tangent phi is the coefficient of friction, then it's obvious what the answer is.
You should remember that.
If you remember that.
Yeah. Along with other 3,576 manufacturing numbers.
I'll be right back. Well, they're not random. I didn't memorize that. I mean, I did remember. I do know that, but this is, I know how to get to that if I forget it.
I just realized it was going to be a cosine. Oh, no, I actually had none before that.
You just have to calculate the force on the piston, which is pressure times area.
Okay, I think I tried that and I didn't get a good answer, so I don't know what I did.
And then you go pressure or stress.
Millimeters, centimeters.
Stress equals force divided by the area that you need.
There's a lot of unit issues in that.
So do we still need to do 40?
Okay, we do 39
Thanks, Steve.
versus 39. 39 the moment.
Oh, yeah.
39 moments and shear don't make sense to me.
Reading that
Oh,
graph,
I
I was
was
like,
up
it's
too.
voodoo magic.
These graphs are like they make them up or something.
Yeah.
Oh, I had to answer anyways.
Well, we have load, shear, and
Look at it.
moment.
I got it right for some reason.
I did
I got it right the first time.
But I think,
I got the absolute longest I could get.
isn't the moment the sum of the, whatever it is to the left of it? It's like the double
Moment.
integral with the shear.
I'm not sure if the shear graph is tough.
So, this is 12, 14, 6,
Over. Oh, it's got the sound effects.
Alright, so this is shear. The moment is the area of this.
I thought
Moment is the area. Okay.
Yeah.
I wasn't.
So
See,
moment
that would've helped.
is the integral of shear,
Yeah.
dpx. Okay.
Why is that?
Because you got me the right answer.
Because V is dm dx. So
Okay.
a lot of times we can solve for a moment in a cross section
Yeah.
and then integrate it once and get, not integrate, take derivative.
I like your view there.
So anyway,
Not an English major.
you know, from this point, it says that there is no external applied moments, right?
Yeah.
Mhm.
Because otherwise there'd be some concentrated moments that would have a shift, a step change in the moment diagram. But if we were just wanting areas, you start stepping across to get to this point. I would say like the average here is 13, so you have 13 times 2. So that would be
26.
26. So this would have to be 26, and it would do something, probably something like that. Because this is linear, so this would be parabola.
So you're doing it on the screen.
And then this becomes a positive 6. We have to come up with, so it's going 6 to -4 really, in a 10 span. So it's 1 to 1, right? So this would have to happen at 6 past this point. So this is, the area of this would be 1/2 6 times 6, which would be 18.
Mhm.
So we add, because this is negative, this is positive, so we'd add 18. So when we get to this point, we should be 8 plus 18 from here. So then this was this. This is positive, which is the slope here. So it's positive, but it's getting less positive. So it's positive, but it's getting less positive. So it would do something like that. That's 0 here, so that has to be horizontal. And then from here to here, this area would be 1/2 4 times 4, which would be 8. So then this would have to go back down 8. So this went up to 8. Is this -8?
Minus.
Yeah.
Yes, that's right.
Is that true? Yeah, that's right. Because we went up 18.
Yeah.
And now we're going back down, what did I say, 8. So this goes down to 16. And then this goes back up, and a straight, this constant means it's a straight slope. And this was 4 meters, so that would be, just going straight back up.
0.
Yeah.
So they're asking for the maximum magnitude of bending moment, which would be this. Wow. So you could start from either end. And, you know, in this test, for sure, you want to kind of see, okay, where do you think the maximum is really going to be? So then you would start from that end.
Just look at it that way, you probably guess that the maximum would be right there at the first one, just because the values are so much bigger.
Maybe.
Not necessarily, but that'd probably be where you start.
Yeah.
Or if you had to guess.
If you were guessing.
Yeah.
Yeah. Well, the deal, just remembering that it's the area that is of the shear that is the moment, so just finding the area of these different blocks. So you could, you know, first cut, I would think you would want to say this is minus 26, this is plus, what did it say that was? 6 times 6 is plus 18, this is minus 8, and this is plus 16. So at all of these steps, all you have to do is keep adding these numbers, you know. So you could actually get these numbers just from getting these quick areas and just, you know, you find the one that's the maximum. So what if you were given this one when they ask you for shear?
Integrated.
You grade it?
Integrated.
Differentiate.
Integrated. Call it names.
You would so be
Culturally
graded.
Or differentiated.
Are you biased against blue?
Yes.
I can use a different color. I like markers of color.
Which one's your favorite?
Red and yellow, black and white. All right, what else? 40. 40, I thought we just talked about 40.
Yeah, were you talking about 40?
Yeah.
Okay.
So we have a pressure, we have a diameter. The design stress is 68 megapascals.
Could you 46?
About 41.
Yeah,
Oh, 41?
41, yeah.
Speak 41. There's an equal formula for 41.
What's that?
Tau equals PR over J.
I was like, I read it like 5 times.
Well, what do you know?
That's
There's somewhere in there.
Okay, so torque transfer. So the torque, the shear stress is the torque times the radius maybe, over J. Is that it?
Yep.
Yeah.
So the torque is what we're looking for.
Yep.
Torque is tau J over R. So we have the shear stress allowable. Well, first of all, this says it's parallel to the grain of the wood. And so we have that it is grain parallel to the neutral axis, so that has to match. Which is on wood. So we've got
So the greatest parallel. Yeah.
probably wood. You get that?
Oh.
And J, for a,
Pi-
say,
1/2 pi d squared.
diameter, so this would be pi, is it pi d to the fourth?
1/2
1/2 d they said was the answer.
The answer's C, right?
Gave it to me.
I think it's A.
C.
Oh, it's C.
C.
Oh, never mind.
So half the battle is just understanding what they're asking for and reading it carefully and not going off quickly and trying to solve it.
I could have
47.
46 and 47.
By the way, how did you guys do on this overall?
You got 32 out of 60 on the first half.
It was solid 60%.
60%?
64. I got about 50
in the first
in
half.
the morning.
If you get 60%, that's passing, I'm sure.
I didn't,
passing?
I didn't do
Okay.
as well. I didn't do as well.
Let's see
in
if I
the
can do it on that day.
afternoon session.
Well, this is harder than the real test,
Is it?
as I've been told.
Really?
Yes.
That's a, well, that's a good thing.
Wait, isn't this just questions from Olivet?
I'm just telling you what seniors tell me after the test. The thing that you give us is harder than the real test.
Wow.
That's all I can say.
I don't trust them
I'm saying that.
I can say the last 3 years, everyone passed but one person. So I've got the same expectation for all y'all.
He's a good young person.
Mr. Bach. Mr.
It's gonna
Bach.
be the one.
No one wants to be that guy.
Even you, Nate.
Don't be that
He's turning red.
Go,
Sit down. 46 and 47?
Yeah.
Aluminum crimp connectors used to connect a copper wire to a battery.
Oh, yeah.
What would you expect to happen?
There's always corrosion everywhere in batteries.
There is always corrosion, yes, but which side is going to corrode more?
Seems like always
That will
both
vote.
over. It's only the
One of them is more electronegative.
Or no,
That
it's
affects-
one of them. I remember which
Well,
one.
it's not the copper, 'cause I got it wrong.
It's not both, because you got it wrong.
I think it's B.
Yeah, it is B. You got it
Because I
right.
put that in the eraser. I remember being mad about that.
Aluminum is anodic relative to copper, therefore will corrode to protect the copper.
Because I remember that they used to plate aluminum with copper. Or that's how you can do it, like with zinc and stuff. So I was like, oh.
Yeah, and that's why they put aluminum, magnesium, and attach it to steel, because it will
Corrodes
corrode and
faster
steel
than-
will not.
Yeah.
So the more
They
electronegative
they
one.
call that something. I don't remember what it's called. Where they put a piece of metal on it so it doesn't corrode. So that corrodes before the material they don't want to corrode corrodes. That's not-
Electroplating?
What?
Electroplating?
No, it's,
That might be the process.
There's a name for it.
is it called galvanic, the galvanic
That's
effect?
it. It's
Galvanization.
Well, that's why you galvanize steel,
Yeah.
yes.
But there's like a name
Put zinc on
for
it.
the metal that you put on something. It's like the dummy metal or
Galvanized
something
agent.
like that. I don't know. I forget. It's been too long since chemistry for me to remember. I know the name.
Well, sometimes we talk about that in material science.
Yeah.
With you guys, we may not have.
I don't think.
Because I didn't like you guys as much as other classes.
We noticed.
Juniors.
What?
Didn't like the juniors either.
No, I don't like many people.
You cranky old man.
I'm getting crotchety, I'll tell you that. I'm letting people have it these days. Wait, nobody will fire me? I'm like, just suck
Cut this.
My brain was
Hey,
beginning
guys.
to melt at this point, so.
Yeah, that's true.
So
I had a really
it
hard
hurts a
time
lot
carrying.
more at the end than I did at the beginning.
Like after the first hour, I was like, I don't care anymore. Damn.
Yeah.
Me too.
Cause like right through the middle, I was like hitting my stride, and then I got like 8 in a row, and I was like, oh yeah, and then like at the end, it was like miss. Yeah.
So how do we start our section?
You know, this,
Pretty good.
Yeah, I got it.
this pressure goes like this,
Yeah.
right?
Yeah.
So the CG of that pressure times area.
So you find the pressure at the, that, this depth of the centroid?
Yeah. And this is the force.
I remember something about that.
I remember.
Oh, yeah, you have to
I
do
remember
different.
we did this.
This is some
We did
moments
a bunch.
of that.
Yeah.
Did it say that the force was defined?
Yeah. It's just like yeah. It's an equivalency. But it's like a It's like a distributed load, but then you get the equivalent force right there.
Yeah.
So you get the pressure here times the whole area.
Yeah.
So this is pressure.
Pressure is rho GH.
Yes.
Right. Capital P. So this would be 1/3 of the 3 meters, and this would be full 3 meters.
Yeah.
So we've got minus P times 1 plus F times 3. So it's 23,537
Yeah, sounds great.
kilonewtons, 24. So let's see, is C the right answer? There you go. I noticed in one of these, afternoon or morning, there was a little buckling problem. Did you get that one out there?
Oh, was it the Oiler one?
Yeah.
What was the actual problem?
Oh,
What?
nice.
There was spring on top.
Maybe that wasn't.
Yeah, the spring on top.
Oh.
In which section?
Oh, that's in the others. This
I
is
just neglected
this
the
one.
Is it in the afternoon?
I know, me
Yeah,
too.
must be.
So it was
I did much worse than me.
I had 11 out of
number
30.
13 in the afternoon.
Right or wrong?
Long. I know, I got 11 right. I think it was just cause
Ooh.
I was frustrated at that
I
point.
got 16. Yeah, I think so too.
Oh, 13.
Yeah, 13, I missed.
Can I erase this?
Yeah, I missed that too.